Find the Taylor series expansion of e power of x cos y in the neighborhood of the point 1 comma pi by 4 up to the third degree terms. So here the given function is f of x comma y equal to e power of x into cos y, and the point is given by 1 comma pi by 4. So from this, a value is 1, b value is pi by 4. Okay, so now we know the Taylor series formula. This is Taylor series formula. For this formula, I want to find out f of a comma b, fx of a comma b, fy of a comma b, etc. So that I am going to form a table. So first form a table. Okay, so in the table, first serial number f of x comma y, this is f of a comma b, a is 1, b is pi by 4. Okay, and now next, first f of x comma y given function e power of x into cos y. So here f of a comma b, x is 1, y is pi by 4, e power 1 into cos pi by 4. Cos pi by 4 is 1 by root 2, therefore e by root 2. So the first term over. Next, f x of x comma y, x means partial derivative with respect to x, e power of x differential same e power of x. So no changes, so fx of a comma b is once again e power 1 into cos pi by 4, it is e by root 2. Okay, next I am going to differentiate with respect to y. Fy of x comma y. Fy means differentiate partially with respect to y. Cos y differential is minus sin y. So minus e power of x into sin y. So that fy of a comma b is equal to minus e power 1 into sin pi by 4. Sin pi by 4 also 1 by root 2. So this is minus, so minus e by root 2. So second term also over. Third, fxx of x comma y. Fxx mean again you will be getting same value because e power of x differential same e power of x cos y. So that fxx of x a comma b is equal to same value will come. Same e by root 2 will come. Next, fxy of x comma y. Fxy means already we found fx. Here I want to differentiate with respect to y because fy. So y differential means cos y differential minus sin y. So that it is minus e power of x sin y. So that fxy of a comma b is minus, so minus e by root 2 will come. Okay, next fyy. Fyy of x comma y. Already we found fy, one more time with respect to y, sin y differential cos y. So minus e power of x into cos y. So that it is fyy of a comma b is equal to minus e by root 2. So this is also over. So next I want to find out third derivative because the question is up to third degree. Up to third degree means we want to find out three derivatives. So fourth term. So x of x comma y. It is again same value differential means same term will come. So x of a comma b is same e by root 2. And next y of x comma y. So already we found two derivative with respect to x. Now I want to differentiate with respect to y. Cos y differential minus sin y. So minus e power of x sin y. Okay. So now fxy of a comma b. So this is minus, so minus e by root 2. Next fxy of x comma y. So yy means already xy we found. So with I want with respect to y. So with respect to y means sin y differential cos y. So here minus e power of x sin y differential cos y. So this is fxy of a comma b. It is minus e by root 2. The last one, f y y y of x comma y. Already 2 time differential with respect to y over, 1 more time with respect to y, cos y differential minus sin y, minus of minus plus, so e power of x sin y. Therefore f y y y of a comma b is equal to, put x equal to 1, y equal to pi by 4, so that e by root 2. So we found everything. Then you substitute in the formula, we get the answer. Okay, so now I am going to substitute in the formula. Before that, h is equal to x minus a, but a is 1 already, it is given, so x minus 1. K is equal to y minus b, b is pi by 4, so y minus pi by 4. So now I am going to substitute in the Taylor series formula. So the Taylor series f of x comma y is equal to f of a comma b, it is e by root 2 plus 1 by 1 factorial into h is x minus 1, h into fx of a comma b, e by root 2 plus k into k is y minus pi by 4, k into fy of a comma b, so minus e by root 2 plus 1 by 2 factorial into h square into fxx of a comma b, it is e by root 2 plus 2hk into fxy is minus e by root 2 plus k square y minus pi by 4 the whole square into fyy of a comma b, it is minus e by root 2. And then next third one, 1 by 3 factorial into h cube into fxx of a comma b is e by root 2 plus 3 h square into k into fxxy of a comma b, so minus e by root 2 plus 3 h k square into fxyy of a comma b is minus e by root 2 plus k cube y minus pi by 2 the whole cube into fyy of a comma b is e by root 2 plus etc. So this is the substituting in the formula. Now to simplify, you can take e by root 2 completely outside, or we can leave it. This is the answer of the problem.